Hello friends, in this video we are going to see about the basics of ICT nameplates, which means what and all the things will be mentioned in our ICT interconnected transformer nameplate. First of all, this consists of a transformer, which means the interconnected transformer windings, then the CTs and the corresponding CTs with which the secondaries are being mentioned in here, and also the vector group of our ICTs. Then here the 1U, 1V and 1W are the primary side of our ICT. Then 2U, 2V, 2W are the secondary side of your transformer. This transformer is a star delta type transformer, and the vector group is YNDN11. Here the 11 in the vector group, 11 position indicates the current leads by a 30 degree, or it is at a 30 degree phase shift, which means 330 degree phase shift of our primary and secondary. Then it consists of a taps, which means the tap position indicating also this ICT condition consists. Then another thing is that here the CTs are being given, and the CTs are in used for measuring and also for a protection of our ICT, which means the winding ICT of our winding can be protected by using a transformer protection relays. Then also there is a one CT connected in our neutral side, so we can take a restricted earth fault protection also. Then the transformer connected with the bus bars, so the bus bar protection also can be carried. Then this is your transformer nameplate, in which the tap positions are being indicated. Here the CT nameplate details also been given, in which the CT ratios are being mentioned. Then the ICT's nominal voltage, which means the primary voltage and secondary voltage, and how the coolings are being taken, like using oil forced, air forced, or oil natural, air natural, oil natural, air forced, or oil drained, air forced. Likewise here mentioned as a OFAF, which means oil forced and air forced. So this is your cooling type. Then and also the CT protections which have been taken for the ICTs are given in another video separately, so you can refer those videos for getting more knowledge about this. And also one more thing is that the testing of these ICTs also like a normal transformer only, which means how the normal transformer insulation resistance, winding resistance, voltage ratio, tap turns ratio for each taps. Then short circuit, open circuit, which means magnetizing current test. Then SFRA and tan delta for the bushings, tan delta for the windings. These all testings are also been carried out in the same procedure wise. With the extra in here we have a two secondaries. So by keeping the primary, we will take for one secondary, and keeping the primary, we will take for the second secondary, which means for the HV and medium voltage and HV and low voltage, this comparison will be taken. Then the main thing is that the cooling system will act according to their megawatt level, which means the kilowatt level, or according to their load conditions, the cooling system may change, like air forced and oil forced, air natural, oil natural, air natural and oil forced. Likewise, it will be changing. Next, the main thing is that it is an interconnected transformer, so it has a more than three different types of voltages. High voltage is 400 kV, then the medium voltage is 132 kV, and low voltage is 33 kV. In here, at the high voltage level, minimum high voltage is 440 kilovolt, and maximum voltage is 440 kilovolt, minimum is 360, nominal is 400 kilovolt. So according to their OLTC tap position, it can be set. So here the OLTC taps here is 17 numbers of OLTC taps, which means in first tap it will be a highest voltage level, and at the lower tap it will be at a minimum voltage level. At the medium level, for a nominal voltage, we are having a midpoint of a OLTC tap position. Then the next thing is that the OLTC is only at the primary side of our transformer, so the secondary is connected to the load. We cannot change the load end, it will be very risky for us, so we are going with the primary of our transformer. Then another one thing is that the secondary, as I said, there are two secondaries. One is 132 kV, which is medium voltage, and another one is 33 kV, which is a low voltage system. In this station, we have a 133 kV bus also. So only we are taking a 132 kV supply also from the interconnected transformer. Then the 33 kV voltage will goes to your low voltage switchgear, which means medium in switchgear level. We will use in auxiliary systems. We will use a 33 kV voltage system. Then the 33 kV voltage system will again step down into a normal three-phase supply, which is used in our industrial level, which means which is used in our normal applications as a 415 volt or 440 volt voltage. Then next thing is that it carries off this, as I said, this three voltage level. In between the winding also the transformer relay, which means the transformer protection have been taken, so it will act like an all the three windings will be combined together. It will act like a teed protection, which means one single incoming with a number of outgoing feeders, which means it will compare one single incomer with the number of outgoing feeders. In here we have two outgoing, one is 33 kV and another one is 132 kV. So likewise the protection have been taken internally in the transformer also, and also comparing with the neutral side, we will take a restricted earth fault type of protections also. Then impedance protections, backup impedance, likewise that kind of protections also been taken in the interconnected transformer. Then most of the things I have carried, I think so. Then the CT itself mentioned as it's a metering or a PS class or a 5P15, 5P20. Likewise, the error according to their errors, thus in CT itself this and all mentioned. Then next thing is the valve schedule plate. This is the overall diagram, which means the connections of the valves in our transformer. In here there are a numerous number of valves, which means normally it may be a drain valve, shut up valve, or it may be a like a draining type of valves, or it may be connected to our breather or any other transducers, which means PT100 type of sensing devices. So in that case also the valves need to be provided. So in any kind of leakage or any kind of pollutant or a broken condition of our external devices, these valves may protect the leakage. By closing the valves we can avoid the leakage. So for this we are having a numerous number of valves in the overall itself. We can able to see, maybe I think so. Then it consists of a conservator tank. That conservator tank, which carries a main, which means which will carry some oil, and the main tank which has a main oil level for the ICTs. Then the cooling systems also been uh, shown. As you know, the number of fans have been given in here, and also the radiator system, how the radiator is acting, and also the uh, another thing is that in here the number of valves to be opened and closed during at the time of operation, because all the valves need not to be in a open condition, or all should be not in a closed condition. While at the time of filling or vacuum, you need to see you need to open some of the valves and need to close some of the valves. So as per procedure, the valves need to be open and valves need to be closed during at the time of operations are being mentioned in here itself. Then the main thing is that the radiators, how the radiators are functioning, are also been mentioned. And during at the time of transport, what and all the things need to be checked, what and all the valves need to be arranged, that to have been mentioned. Then how the conservator tank is connected with our main tank, and also the OLTC conservators, and also the oil filling nozzles for the OLTCs also been mentioned in here. Then these and all the main things need to be carried out while at the time of oil filling of your ICT main tank and conservator tank, and how these are functioning at the time of operation. These and all the main things mentioned in here. Hope this is the main basics of the ICT nameplate. These three nameplates will be mentioned in all the most of the ICTs. Thanks for everyone who supports me, and keep watch my video for getting more knowledge. Keep sharing your knowledge and gain your knowledge. Thanks everyone. Nandri, vanakkam.